Hello and welcome to this screencast. My name is Thomas Lehmann and I would like to show you how to do comet photometry using my airtools software. Please keep in mind that this is not intended as a full tutorial, but rather gives a quick outline of the workflow. Let's start up. I have unpacked sample files which created this directory, and for convenience I provide a startup script which I'm going to execute, and this opens up the main window. It's an SAO image display window and it has some analysis tasks, and here's where the airtools software comes in. We do have two images. First image is a stack on stars. It's a comet observation from this year, and the second image is the same observations but stacked on the comet. The field of view of these images is about 5 degrees, so it's a rather large field and it's close to the Milky Way region, so it's a lot of stars around. We are starting with astrometric calibration. Analysis menu and astrometric calibration. We have the choice to either use UCAC4 or some other catalogs here, and due to the large number of field stars we should probably limit to the brighter ones. And it first contacts the reference catalog and now does all the matching and computations automatically. So finally we are presented with some plots. First of all, plots of residuals in X and Y coordinates. Second is a plot of pixel scale distortion map. And the last one is a map of star detections. Everything looks fine here. I'm closing this. And we have some information about the accuracy of measurements down here in this message output window. Okay. The next thing we are going to do is background gradient removal. For this we need to stretch up the image to very high contrast, and you see already there's some gradient. It's brighter over here, darker here. At first we should mark this star cluster and other areas of the image which should be excluded from background fitting. And we start the task accepting default parameters. I'm not going to describe all the parameters here. We get some background residual images at low resolution after subtracting the gradient, and second image we can switch between images by the tab key. Shows the gradient, so it's brighter up here. There's some indication of flat field inaccuracy. There's some depression over here, and this can be measured, and in this example it's about 1%. Let's close those windows and continue on extracting the point spread function. Again, we accept defaults here, and it's now extracting all sources from the whole field, which is quite a lot. It's about 16,000 field stars, and it first tries to model the point spread function by using a few bright stars and removing close companions over there, and it goes through a second iteration, and it does the same kind of operations on the comet stacked image. That means you're also modeling the point spread functions from the star trails. This takes some time. And finally, we are presented with some check images which show the point spread functions at 4 times the original resolution, and it looks pretty nice. The first image is a point spread function on stars, second on star trails, and the third image shows the extent used later on for subtracting stars and star trail images. I'm closing those windows. There's also a check image here in the main window which indicates all stars used for creating the point spread function, and you can have a look at the residuals, and maybe you need to eliminate some of those stars. Let's look over here. If you have companions which were not removed, you could flag those stars by selecting it and pressing the O key and rerunning the PSF extraction. We don't do it right now, and we continue with the next step, which is the comet extraction and large aperture photometry. Again, we accept all the default parameters. And at first we need to define some areas manually. So we get a first window, and it's also written here. We have now to define regions for the comet area and some background areas, and maybe we need to define some bad background areas, for example, due to bright saturated stars. We would like to eliminate from all following measurements. So let's start with comet. This is already star trail subtracted image and slightly blurred to have a better contrast, and we stretch the contrast to the really extreme case to get the real coma outline. We define this coma region and save it to file. Okay, and we continue on background. We should probably choose 4 or 5 regions. This gives the opportunity to measure some statistics on background variation. Saving those to file. And that's it. Next, we are presented with a new window allowing us to mark some stars which were badly subtracted, maybe double stars or things like that. We have first an image of the star stack and indicated the regions we are going to use for measurements, and pressing tab we switch to the image where all stars were removed and also the comet. And zooming in, you will see some stars which were not perfectly removed, or some stars which did not get any detection yet, you could just mark those positions like here, and you should also check the background regions. That looks fine. Again, well, it's not bright. Okay, here there's a source from a double star which was not detected as a source being to be subtracted, and we need to manually select it at this stage. We are saving the region as indicated here on the message window to a file x newfot.rec. These are the stars which get new measurements of their photometry now. And the results of the photometry is written to the message output window. We have one star which now got a correction of about half a magnitude, and two other stars which were newly identified and now get included in the star and star trail subtraction. After subtracting the stars, the program does now measurement of the counts in the comet area and also in the background areas, and prints out some statistics over here and displays several check images. First of all, we have again the residual image. That means image after subtracting stars and comet. Going backwards in the stack of images by using Shift Tab, we have the star subtracted image, the blurred comet image, and the unblurred comet image. Now, as the measurement of counts is finished, we could do some additional measurements, for example, of the dust tail of the comet. We choose a vector shape here and measure the tail, length and angle. We should probably copy over to this blurred image where we have a much better contrast, and we see that the tail is extending further away, maybe like that. Double click on the shape, gives the measurements of the tail, and we put data in the form which is available from this menu item. We enter dust tail measurements here, length 671, angle 239. Okay. So now it's time for the last step in the reduction pipeline, which is photometric calibration using reference catalog stars. Currently, the program is able to either contact Tycho 2 or APAS catalogs. With this wide field image, we are fine using the Tycho catalog here. And it queries the database over the internet, downloads all the stars from the field, and does measurement on the brightest 100 sources. That takes a little time, and finally we get two plots. One plot over here shows the large aperture correction from measurements on stars at different radii, and the other one is a plot of photometric errors, and that looks pretty good. We might have some outliers, and the program itself makes some suggestions for outliers. And just to give an example, we could just copy the list of identifiers over here and rerun the photometric calibration. But this time we are going to use the skip parameter, and it's now going to exclude the star from the fitting procedure. And finally we have our photometric measurements in form of an ICQ data record written down here, and we have the comet designation, magnitude, and information about the telescope, the size of the coma, and tail length and angle. So that's it for now. I hope you could enjoy this quick demonstration of the airtools software, and for more information please visit the project page. Thanks for watching.